Hello, this is Paul from First Attack. In this video, let's prove the Theorem 3.4.2, which is a vector equation of a plane in 3 space. We do have a point normal equation before, right, for a plane. Here is another type of equation. See, suppose in 3 space, given the point x0, given 2 vectors not parallel to each other, then equation of a plane, D plane, go through x0, the given point, and also parallel to the given 2 vectors. Okay, imagine, and then the equation is like this. And then we do have a 2 parameter T1 and T2 to describe the plane. Why the equation is like this? So let's look at it. Okay, we need this small graph. Give you 3 space, give you the point or a given vector x0 is here, and they give you another 2 vector. Okay, suppose let me draw. Suppose here is v1. Okay, is another vector. Suppose here, okay, is v2, another vector. Imagine now, of course, okay, a point and then 2 vector, because the 2 vectors are not parallel and they go through this x0, just after shift. Okay, definitely form a unique plane, no problem, right? The plane is unique, and then among the unique plane, we need to describe the equation of any point like x, okay, or a vector x. So what is the equation for that given point, any point? So we can easily to do this. Okay, this point we can draw a parallel line, a straight line parallel to v1, and then draw another parallel line parallel to v2. Therefore, we form a parallelogram. Easy, right? And then now look at what is the diagonal. Okay, this is the diagonal. The diagonal exactly is from a point x0, point to x, right? So we get it by the difference, the definition of the difference of 2 vectors. The diagonal should be x, for example, say x minus x0. This should be the diagonal. Remember, the diagonal should be the sum of another 2 vectors, right? So therefore, one vector is v1. Extend a little bit, which is collinear. That's T1 times V1. And another vector is V2 extend a little bit, which is T2 times V2. Therefore, and this diagonal should be the sum of V1 and V2, right? Okay, so let me write. So because x minus x0, okay, this is the diagonal. Imagine this is the diagonal of this parallelogram we constructed. Therefore, this diagonal should be equals the sum of the another 2 sides. Okay, by the definition of the sum, one is T1 V1, right? Another is T2 V2. Okay, that's the equation. And easily to solve the equation, we find that x should be equals x0 plus T1 V1 plus T2 and the V2. See, and this exactly is the equation, right? We do have 2 parameters, T1 and the T2. Okay, both the T1 and the T2 belongs to real number. Okay, so T1 and the T2 are real numbers. Okay, so therefore, this is a vector equation for a plane. Go through a point and parallel to one vector and another vector. So that's the equation 1. We have a special case. Okay, but if x0 is 0 vector, the origin, therefore this disappears, right? So the equation of the plane should be x is a linear combination of v1 and v2. Exactly is the plane go through the origin. Okay, that's all. Thank you.